For these problems, you can use a calculator for the arithmetic, but it's not necessary for actually solving the system. What I like to do is reorganize the set of equations here, and I like to write it where I can line up all of the x terms, the y terms, and then equals the constants. Because then what this shows me is if I label these equations, equation A, B, and C, if I, let's say, take equation A minus C, I'm going to be left with just a y and z. So if we have, here's our A equation, our C equation, and if I take this equation away from the other one, those are 0, we're left with 2y minus, because we're going to subtract everything, minus 3z equals 7 minus 17, negative 10. And now what I can do is combine this equation with the y and z with this equation with the y and z. So in order to do that, I need matching coefficients so that I can eliminate a variable. I'll multiply this bottom equation by negative 2. Let me rewrite the top equation. And when we add them together, we get negative z equals negative 4. That means our answer for z is 4. Well, now I can use that back in here to find y. I'm going to add the 4 to the right-hand side, so y is 1. And now I can use both of those to find x. So what I'll do is I'll take this y and plug it in here to find x. So x plus 2 equals 7, so that means x equals 5. Because we have 3 variables, when we write our coordinates, it's x, comma, y, comma, z. So for the answer for 29 then is going to be 5, 1, 4. Okay, so now number 30 is already lined up for all our equations. So I'll call the top one A, the middle one B, the bottom one C. So I need to eliminate one variable using 2 different pairs of equations. And I notice the z variables all have a coefficient of 1. And also the first equation has a negative z. So if I take equation A plus B, the z's will cancel to 0. And if we take equations A plus C, the z's will cancel to 0. So for the first pair, x plus y minus z equals negative 2. So when we add them together, we get 4x minus y equals 9. Now doing that with A and C, and then we take our C equation, we're going to add them together, and then actually this is really nice because if we bring our other 2 variable equation over here to the right, our x's, if we add together, already equal 0. So we're left with y equals negative 1. So there's our first value. So now we can take that and plug that back in here. We could have chosen this y as well to plug it back into, but it's just easier to use a y without a coefficient. So minus a negative 1 is plus 1. We subtract the 1 to the right-hand side. We're going to get x is 2. And now we can use both of these values and find our z value. And I'm going to use equation A to find z So that's 2 plus negative 1 minus z equals negative 2. 2 plus negative 1 is 1. We're going to subtract that to the right-hand side, and we get z equals 3. So our coordinate answer is 2, negative 1, 3. Now for 31, when we look, unfortunately, none of the x's, none of the y's, and none of the z's have matching coefficients. So that means when we pair up our equations, we're going to have to multiply one equation by a constant so that we get a variable that eliminates. I noticed that in the b equation, the z is already negative. So if we take equation A plus 3 times equation B, we'll eliminate z. And if we take equation C plus 4 times equation B, we'll also eliminate z. Now with this problem with the 18 and the 17, this one might be handy if you use your calculator for the arithmetic. That's why these questions are not no calculator. So I'm multiplying everything in this b equation, every number, every coefficient, by 3. So then 18 times 3 is 54. And when we add our equations together, so we have to repeat that process with C and 4b. So I'm going to take the b equation all times 4. And add them together. So now when we're going to eliminate the y variable, because these coefficients are smaller numbers than the 23 and the 19. So we're going to take this equation times 5, and we're going to take this equation times 7. I purposely did not pick which one I wanted to be negative yet, because now that I see these values, what I'm going to do is make this top equation all negative so that when I subtract my answers are going to be positive values. So let's see, 198 divided by 66 is 3. So x is 3. I'm going to choose this equation to plug that back into. 19 times 3 is 57. So that's 57 plus 7y equals 71. Subtract the 57. So we get 7y is 14. So that means y is 2. So then last but not least, we need z. I think I'm going to use the b equation to find z. So 5 times 3, because I'm going to take this 3, plug it in here. That's going to give me 15 plus, I'm going to take this 2 and plug it in for the y. That's 4. So 15 and 4 is 19. When we subtract that, we get negative z is negative 1, so that means z is positive 1. So your coordinates are 3, 2, 1. Okay, now for 32, notice that in this equation we have y equals, and this one is z equals. So nothing is lined up like I did in the first problem. So what I'm going to do is rewrite all the equations so that they're in the same format. I'm going to subtract the 3x and leave the 1 by itself on the right-hand side, and I'm going to subtract the 2x and leave the negative 5. So now I'm going to work with these three equations to find my x, y, and z. So if I combine a and b, I can eliminate either x or y. Let's say I'm going to eliminate y. That's going to leave me with x and z, just like this equation is. So what we're going to do is I'm going to take a plus negative 2 times b so that is 6x minus 2y equals negative 2. When we add them together, we get this equation. So now I can combine that with the c equation. So if I multiply c by 3, do that over here. If I take the c equation, so I'm going to take my new equation, and I'm going to take this c equation, which is this bottom one, and multiply it by negative 3 so that my z's are going to cancel. And that's a negative 5, so negative 5 times negative 3 is 15. Add them together, so x is 2. So x is 2. So, we can use that here to find z. 3z equals negative 3. Z is negative 1. Because what we can do is we subtract the 14 to this side and then divide by 3. And then lastly we need y. So I'm going to use this middle equation to find y with this x value. So that's negative 6 plus y equals 1, so y is 7. So our coordinates are 2, 7, negative 1. Okay, and lastly for a word problem, we have to define our variables. So I'm going to say x is the cost of a burger, y is the cost of fries, and z is the cost of a shake. Now there's actually a typing mistake in this problem. For the first equation, the 4 burgers, 1 fry, and 2 shakes, this number should be $24. So now when we write our equations, each sentence will give us one of the equations of the system. So 4 burgers plus 1 fry plus 2 shakes costs $24. 2 fries and 2 shakes, 2 burgers, 2 fries, 2 shakes, it's $18. And lastly, 4 burgers, 3 fries, and 1 shake is $25. So now we have our choice about which variable we want to eliminate first. I think I might do the z variables again, because if I multiply this third equation by negative 2 each time, we'll be able to cancel the z's. So I'm going to do a plus negative 2 times c and b plus negative 2 times c. So I'm going to rewrite my a equation, and then negative 2 times the c equation, and when we add those together, now the same thing for the b and the negative 2c. I'm going to rewrite my b equation. And then negative 2 times c. And when we add those together, So now, looking at the two equations we have left, we can either cancel the x's or the y's. I think I want to cancel the x's. So I'll multiply this equation by 4 and this equation by 5. So we get negative 16x minus 20y equals negative 104. And then this equation by 5, negative 30x minus 20y equals, what is that number? 32 times 5, negative 160. So now I'm going to choose to make the bottom equation negative, or I'm going to multiply the bottom equation by negative 1, so that when I do 30 minus 16, my answer is going to become a positive x. And then 160 minus 104, we get 56. And then as a last step, we're going to divide by 14. And we get x is $4. So now I have to take that x value and substitute it into an equation. So what I'm going to do is I'll take the 4 and I'll plug it in for this x. So that's negative 16 minus 5y equals negative 26. We'll add 16 to both sides. So negative 5y equals negative 10. So y is $2. And then lastly, we need to find z. So I need my original equations, and I think to find z I will use equation c. So when I plug in 4 for x and 2 for y, we're going to get 22 plus z equals 25, so z is $3. So to finalize our answer, the cost of one burger is $4, the cost of one French fry is $2, and the cost of a shake is $3.